Hello, I'm Pascal Roussel, and some of you may have heard about me because I usually post articles on the financial crisis on my blog, and I even published a novel about the hidden aspect of the financial world. Since I have also a degree in engineering, this presentation will not at all be about finance, but rather about permanent magnets and the possibility to make engines. I saw many videos on the internet, such as those ones. And was curious to see if I could build one of those engines. Before actually building one, I decided to make some theoretical simulations in order to find the best option. As I will show, I came to the conclusion that there are many fake videos, even with a great number of viewers. The simulation file I have developed can be freely downloaded from my blog and used by anyone. Shortly, I will show you some simulation on how forces and torque are generated by magnets in various cases. But let's first review some basic concepts. As we all know, two magnets can attract or repel each other. The force depends on the distance between the two magnets. You can see the formula on the screen. Okay, now let's consider a basic example like a wheel with 4 magnets, and let's see what happens if someone approaches a magnet. Some of the magnets on the wheel will be attracted and some others will be repelled. All the forces will generate a torque, and the wheel will turn to find a new equilibrium point. And once that point is reached, the torque will become 0 and the wheel will not turn. Now let's assume that we have 2 wheels connected with a belt or with gears. In that figure, attraction and repulsion forces are balanced. Torque is equal to 0. Let's imagine that we turn the wheels slightly and we let them turn freely. A magnet on wheel 1 will attract or repel separately all the magnets on wheel 2. All the magnets on wheel 1 will react with the magnets on wheel 2 and opposite. Due to all those forces, a torque will be generated on wheel 1 and wheel 2. Both wheels will turn as long as the torque is different than 0. When a new equilibrium point is reached, the torque will drop to 0 and the wheels will stop. Will probably oscillate a bit around that point and stop. As we see on the picture, the attraction or repulsion of magnets from wheel 1 on wheel 2 is compensated by the opposite action of magnets from wheel 2 on wheel 1. Okay, it's not extremely complex to write a macro in VBA Excel to calculate those forces. Take then the tangential component and then calculate the resulting torque as briefly shown on the picture. Now let's see a first example of the calculations. Wheel 1 has 4 magnets and wheel 2, which is larger, has also 4 magnets, like on the picture we have just seen. Speed ratio is 1, meaning that when wheel 2 turns 1 degree, wheel 1 will also turn 1 degree. As shown on the previous pictures, the torque is maximum at 0, 90, 180 degrees, and 0 at 45, 135, and so forth. The torque is maximum in the clockwise direction, then become maximum in counterclockwise direction, and so forth. Yet in order to have a wheel 2 which turns forever, like on the video, the torque should have a maximum value only in one direction and should have on average a much greater value in that direction. Look for example at the torque on a car engine. As you can see, the peak is much higher in one direction, and on average the torque is much higher in one direction than the other. Now let's see a second example. Wheel 1 has 7 magnets and wheel 2, which is larger, has 9 magnets. Speed ratio is again 1. Torque pattern on wheel 2 is much more complex, but unfortunately the torque oscillates widely, it swings up and down. Wheel 2 can never turn forever continuously. In that example, we are simulating 3 different wheels fixed on top of each other. I have mixed the characteristics. Again, the torque pattern is very complex, but it swings widely. Anyone can test different combinations, but the end result is always the same. Torque oscillates, which means that the wheel will not turn continuously. Now let's see the case of concentric wheels. For example, a turning cylinder with magnets, called a rotor, built inside a fixed cylinder with magnets. We can even add a fixed cylinder with magnet inside the turning rotor. Let's consider a first example where the external fixed cylinder has 4 magnets and the turning rotor has also 4 magnets. The torque is maximum around 0, 90, 180 degrees and is 0 at 45, 135 degrees and so forth. Again, the torque goes from clockwise to counterclockwise with the same amplitude. The rotor will never turn freely. Let's consider a second example, where the external fixed cylinder has 13 magnets and the turning rotor has 9 magnets. Again, the torque oscillates widely from clockwise to counterclockwise and the rotor will never turn freely. Let's consider a third example, same as previous one, except that an internal fixed cylinder with 7 magnets has been added. Again, the torque oscillates widely and the rotor will never turn freely. In that example, we are simulating 3 different rotors and stators fixed on top of each other. I have mixed the characteristics. The torque pattern is very complex, but again it swings widely. Conclusion is that many videos with either 2 external or internal wheels are fake. The Excel file can be freely downloaded from my blog at the address shown at the end of the video. It contains 6 sheets. 3 of them are working sheets which should not be deleted. 1 sheet is used to display the wheels, 1 sheet is used to simulate 2 external wheels, and the last one is used for concentric wheels. Sometimes when you open the file, a yellow bar will appear on the top requesting you to confirm the usage of macros. Now let's see how to use the first sheet, which simulates 2 external wheels linked together. Start first with 1 series of 2 wheels. Don't select too many magnets to start. Respect the minimum distance between the wheels and press simply the button. Depending on the power of your PC, the calculation time may be more or less long. Once you get familiarized, you can try more complex pattern. The sheet which simulates concentric cylinder is using the same kind of parameter. Enter some values and press the button. There is a sheet to help visualize how the wheels look like. Now Excel is not designed to do that, so I had to find a workaround where circles are not always displayed as exact circles. But at least it gives an idea of how the wheels with the magnets and their polarity look like. Thank you for watching this video. I hope that it will contribute to get rid of fake videos showing so-called free energy engines with permanent magnets similar to the ones I've simulated. At least it will give a chance to more promising devices to come forward.